Okay, sorry about that fire drill. Segment addition in midpoint worksheet answers. This was part 2 of the worksheet. That's why it started at number 14. Very important worksheet because your partner quiz tomorrow is over this worksheet. So there's 28 problems on this worksheet, 1 through 28. Was this the one that there were 2 17s? I don't know, but anyways, there's 28 problems and your quiz tomorrow is over these 28 problems. Not even really the true-false, so really 1 through 19, okay? All right, number 15. 3 points F, G, and H lie along a straight line. Point G is between F and H. If FG is 13 and FG is 1/3, it's 1/3 of FH. Find FH. So FG is 1/3 of FH. So I put a 1 on FG and I put a 3 on FH. It's 1/3. Put a 1 and a 3. Now those are not the lengths, those are just the ratios. And so part plus part equals whole, so that's 1x, that's 2x, and that's 3x. I didn't have to go through all of that, but I just wanted to show you just in case you're given different pieces of information. Okay, so if I wanted to find FH, I would just take 13 and I would triple it. Yeah, times 3. Because if 13 is 1x, then what's 3x? Well, it's 39. So the answer was 39. Could you have taken 13 and done this? 13 equals 1/3 FH. And then to solve for that, the opposite of 1/3 is 3. So you would just multiply both sides by 3. So that's another way to look at that one. All right, 16. N, R, and T lie in a straight line, and R lies between N and T. If RT is 4/5 of NT, so RT gets a 4 and NT gets a 5, 4/5. It's 4 out of 5. That means this is 1 out of 5 because part plus part equals whole. So when I see a fraction like that, I'm splitting it up and I'm assigning it to the segments. NR is 25. Find NT. All right, so if 1x is 25, then 4x is 100. And then the whole thing is you add them up, 125. Okay, last one of these, 17. Same story, different numbers. Y'all are not allowed to miss this on the quiz tomorrow because I did so many of them. Okay, A, B, C. AB is 54, and AB is 5/6 of AC. So AB gets the 5 and AC gets the 6. So this is like 5x, and this is like 1x, and this is 6x. We're trying to find AC. So the only thing that about this one that's a little bit uglier is that we wanted the one that was 1x to be 54, right? But the 5x is 54. Let's find out what x is. X is just kind of our ratio, and then we'll plug it in. So the part that gets 5 is 54. So we'll do 54 divided by 5. And we get 10.8, or you can keep it in fraction form, 54/5. It was asking for a C, so you just plug it in right here. 6 times 10.8, which is 64.8, or you could do 6 times the fraction, 54/5. And then you can do math, enter, and it's pretty ugly. 324/5. Okay, 19, last one. Given that JK is congruent to LM, KL is 5x, LM is 25 minus 2x, and KM is 4x plus 14. All right, so we've got a classic part plus part equals whole problem. Now you're like, ooh, but it's looking for JL, and I don't know how to find that. But the first thing you do every time is find x. You don't even know what you're going to do with x, but find x first every time. So I've got a classic part plus part equals whole. Problem on my hands. Part plus part equals whole. I'm going to combine like terms. 5x minus 2x is 3x. I'm going to move the 3 over and the 14 over at the same time. So 25 minus 14 is 11, and 4 minus 3 is just 1. So x is 11. Now I'm going to look for JL. What segment is JL congruent to? What other segment is the same length as the distance from J to L? The distance from K to M. Because see how they're overlapping in KL? And then the JK equals the LM? So they're the same. So if I take 11 and I plug it into KM, I'm really finding JL. Okay, so when we take that 11 and we plug it in, 4 times 11 plus 14, we get 58. Okay, homework time is over. So we have already learned how to copy a segment. This is a quick reminder of how to copy a segment. Remember, the cardinal rule of constructions is you can't use a ruler to measure. You can use a compass and you can use a straight edge, but you may not use a ruler. So that's how we work with constructions in geometry. I'm going to move this down a little bit for my compass. So how to copy a segment. The first thing we learned was you put your needle on one end point and you put your pencil on the other end point. Needle on one end point, pencil on the other. Then you take your compass and you don't change the setting and you move it down and just put it right there. No, you have to put your needle on the end point, and there kind of should have been a point there, that would have been nice. And then you just take your compass, you make an arc, you put a point where the arc intersects the segment, and you call it A prime, B prime, because that's what the worksheet said to call it. If it said to call it CD, you need to call it CD. So it's important that you do label your final answer so that I know where the beginning is and the end is. Okay, so that was just a reminder. That's old news, how to copy a segment. Now you do number 1, copy a segment. Okay, here's the good stuff. Here's what we're really doing today. We are going to construct what's called a perpendicular bisector. Now, you don't need to understand really what a perpendicular bisector is. The perpendicular bisector is going to get us a midpoint of a segment. In this unit, we learn about midpoints, so that's why we're constructing this today. Okay, now, so when you're constructing the perpendicular bisector, you have to make sure your first step is that you need to open your compass more than halfway. You need to open your compass more than halfway. So this would not cut it, and if I went, well, I can't go past, but if I went past the end point, that would be too much. So somewhere between the middle and all the way. Doesn't have to be perfect, you just kind of guesstimate. Then you're going to take your compass and you're going to make a semicircle. A nice big semicircle. You're going to leave your compass on that exact setting and you're going to switch it around and put the needle on the other end point. Then you're going to make the same exact semicircle kind of going the different direction. Then you're going to take your straight edge. I don't have a ruler out right now, but you're going to take your straight edge and you're going to connect this point. Uh-oh, Miss Stanton's was pretty bad. This point to this point with your ruler. You just constructed that green segment is a perpendicular bisector. I bisected my segment and I did it at 90 degrees, which we don't really care about right now. All we care about is that the perpendicular bisector, where it hits the segment, that is the midpoint of the segment. I'm going to call it M. So I've just found the midpoint of my segment by finding a perpendicular bisector. Okay? Okay, so the next one on the worksheet you don't have, sorry, says to construct the perpendicular bisector of ST. So, you know, your segment's not always going to be horizontal, but that's not really going to change how you're going to do this. And let's see if I can do it with this one. you're still going to put the needle on one end point, and you're still going to open it more than halfway. Once it's opened more than halfway, you make your semicircle, and then you keep it on the same setting. You put your needle on the other end point, and you make your other semicircle. And then, of course, you're going to connect the intersection of your two arcs, and you have now found M, the midpoint of ST. Okay, so you can have some practice with that once we get you that worksheet. Now, let's just talk about number 7. How would I, with just a compass and a straight edge, divide AB into 4 congruent parts? How would I divide AB into 4 congruent parts? You're not allowed to measure with a ruler, just using your compass and your straight edge. Good answer, Michael. Good. Yay! Y'all got it. And I'm not going to take time for y'all to watch me do the construction again, but you would construct the midpoint, however that works, you know, like that. It's ugly, sorry. And then you would construct the midpoint of the segment that you created, of half the segment. You'd create the midpoint of the half. You do it to the other side as well. These are not constructions. I'm just eyeballing it to show you. And then that would be 1, 2, 3, 4 congruent parts that you end up with. So you kind of find the midpoint of the segment you created by making the midpoint. Midpoint of a midpoint, kind of. You know, I don't even need you to plot this if you don't want to plot this. I want you to find the coordinates of the points that would divide AB into fourths. I just want you to think about how would I, not with a compass now, but with numbers, how would I divide a segment into fourths numerically? Now that we've done it with a compass. So we would start by finding the midpoint. What would the midpoint be between A and B? What would the midpoint be? Good. The midpoint would be 1. And remember, if we're not on a number line, how do you find a midpoint? You add the endpoints and divide by 2. Okay? So then, just like we did with a compass, let's find the midpoint of the segment we created with the midpoint. How do you find the midpoint between -1 and 1? Well, not how. You can just tell me what the midpoint is. It would be 0, right? And then the midpoint between 1 and 3, the middle of 1 and 3, add them up and divide by 2, and you get 2. So, if we use this method, what fractional parts would this get us? We can find halfway across a segment. We can find 1/4 across a segment. We can do 3/4. What are our limitations? Which ones could we find and which ones could we not find by doing this method? Finding the midpoint and then finding the midpoint of the new segment and the midpoint of the new segment. What types of fractional distances could we find? We're not in Kansas anymore, right? We're not just finding midpoint anymore. We're finding more. Okay, now 2/3. No. 2/3 and 1/5, no. So using this method, finding the midpoint and then finding the midpoint and the midpoint in that, you can't find anything unless it has a denominator of something divisible by 2. Yeah. Okay? So you could find 1/8. You could find 1/16. But you can't find 2/3 because that doesn't correlate to halving things. You can only find something that can be halved. Okay? All right. If M is the midpoint of AB, what do we know about AM and MB? Well, that's old news, right? We know that AM is congruent to MB. So now we want to find the coordinates of AM, the coordinates of the midpoint, of AM. find the midpoint of AM, and we would need to call it C. Now, up here, if we didn't know the coordinates, we'd have to do the whole rise and run thing, right? 1, 2, 3, 4, 5, 1, 2, 3. And we'd have to take half of that, which is turning out quite ugly. 1, 2.5, 1.5. Call it point C. Okay. What fraction of the length of AB is between points A and C? So it's asking what fraction of the whole thing is between points A and C. What would you call it? Good. That's 1/4. Good. What fraction of the length is between, what if I found the midpoint here? What fraction of the length is AD? If I put a midpoint there, good, it would be 3/4. So this is called fractional distance or fractional length. Okay, let's let you actually try one. Given CD with C at -5, -4 and D at 3, 8, find the coordinates of the point that's 3/4 of the way from C to D. What will be our first step in this problem? Good, midpoint formula. I love the way you think. So, we're going to circle our X's and underline our Y's, and we're going to do the midpoint formula first. Some of us are a little rusty on this, judging from the quiz. So the more practice we can have with the midpoint formula, the better. All right, so we've got -2 divided by 2. That'll get us -1. And we've got, what, 4 divided by 2. So we have found, I'll call it M. We have found the midpoint. We have found the coordinate that is half of the way from C to D. Now we want to find the coordinate that's 3/4 of the way. So now we kind of need to find the midpoint of the midpoint, kind of. Now, am I going to use M and D, or am I going to use C and M? Good. Do the midpoint formula between the midpoint and D, because I want it to be 3/4 of the way. If I did it between C and M, I would be 1/4 of the way. But I want to go further, so I'm going to find the midpoint between D and M. Okay? So, same formula. Add your X's and divide by 2. Add your Y's and divide by 2. 2 divided by 2 is 1. And 10 divided by 2 is 5. So those are the coordinates of the point that is 3/4 of the way from C to D. And if we had graph paper, it would be cool and you would see how it lands right there. Y'all get the same thing I did? You got that? Good job. Okay, now we're on a number line. We're not on the coordinate plane anymore. We've got point X is at -2 and point Y is at 14. You don't have to draw it, but I'm just going to give you all a little visual. So we've got Y, we've got X. Okay, find point Q such that XQ is 1/8 of XY. So that point Q is 1/8, XQ is 1/8 of XY. You got to find the midpoint 3 times? Okay, let's do it. Let's find the midpoint. What's the midpoint? Add them up and divide by 2. Ooh, we're getting such good practice with this. Add them up and divide by 2. What do you get? No. 6. Yep. 14 plus -2 divided by 2. Okay. Now, we want to go this way, right? We want to go this way because we only want it to be 1/8. We don't want it to be 7/8. Okay, so add these up and divide by 2. Okay, and now we want to go this way one more time. So add those up and divide by 2. What was the answer? 0. The answer was 0 all along. Who knew? So 0 is 1/8 of the way from -2 to 14. Yay!